video is on integration using residues. In today's video, we are going to find out the poles and the residues at each pole of 2z plus 1 by 1 minus z power 4. So clearly our f of z value is given as this is 2z plus 1 by 1 minus z power 4. Now for this function we have to find the poles. So in order to find the poles, what we have to do? So we have to equate the denominator to 0. So what is our denominator? That is 1 minus z power 4 is equal to 0. So this can be written as 1 square minus z square whole square is equal to 0. Now this is of the form a square minus b square. So this can be written as a plus b into, again this is a minus b is equal to 0. So if I equate this one to 0 as that is 1 plus z square is equal to 0. See here, this can be written as z square is equal to minus 1 and z square is equal to minus 1 can be written as I square, and here z value is equal to, if I take a root, that is root over I square. So z value is equal to plus or minus I. And next thing here is if I equate 1 minus z square, this is 1 minus z square to 0. Here z square value is equal to 1, z is equal to root over 1 and z value is equal to plus or minus 1. So as it is of power 4, so we got the 4 pole values as z is equal to, see first z is equal to minus 1, so this is plus 1, this is minus I and plus I are the simple poles. See here which poles it is? Simple poles. Now we have to find out the corresponding residue values. So for finding the residue values, here is a formula. See, now we have to find the residue values as our pole values are plus or minus I and this is plus or minus 1. Clear? Now in order to find the pole values, see first of all what is our function value. Our function value f of z is given as this is 2z plus 1 by 1 minus z power 4. First we have to treat the first function as phi of z and next function we have to treat it as xi of z. Now for this our residue value here, the formula here is the residue of f of z at point z is equal to z naught is nothing but we have to leave the denominator as it is. So we have to leave phi of z as it is. For the denominator we have to make a derivative and again we have to substitute the pole value. So this is the process as it is of the form u by v rule. So as it is of the form u by v rule, so this is the formula which we have to apply for finding the residues for the corresponding poles. See the first pole I am taking as, first pole value I am taking as z naught is equal to minus 1. For this the residue of f of z at the pole value z is equal to minus 1 is, so first function phi of z is the numerator I am leaving as it is, that is 2z plus 1. For the denominator I am making a derivative, so this will be minus 4z cube and in this place I have to keep z is equal to minus 1. So if I keep z is equal to minus 1, so this is minus 2 plus 1 by minus 4. So if I keep minus 1, so this will be plus 1. So the value here is minus 1. So this is minus 1 by 4 is our pole value. So therefore the residue of f of z, see here, the residue of f of z at the pole value z is equal to minus 1 is nothing but minus 1 by 4. So this is minus 1 by 4 is our pole residue value for the corresponding pole z is equal to minus 1. And the next one here is I am taking z is equal to the residue value as z is equal to plus 1. Now for the second one z naught, the residue value I am taking as plus 1. Now for this the residue of f of z at point z is equal to plus 1 is nothing but, for the numerator I am leaving as it is as this is 2z plus 1 and the denominator I am making a derivative minus 4z cube and again I am keeping z is equal to 1. So if I keep z is equal to 1, this is 2 plus 1 by this value is minus 4. So as you can see this is minus 3 by 4 is the pole residue value. So this is the residue value of f of z at corresponding pole z is equal to 1. Now This is a residue value at the pole value z is equal to 1. And the next pole value here is, see, the next pole value I'm taking as -1. So this value as -1. If I take -1, see what happens. So z naught, if I take -1, see, our residue value of f of z at z is equal to minus I, sorry. Here, the first function we have to leave as it is, that is 2z plus 1, and in the denominator we have to make a derivative, that it is minus 4 by z cube, and again we have to keep z value as -1 here. Then we'll be getting the residue value, that is minus 2i plus 1 by here minus 4 into this is I cube. So as you know that this is 2i plus 1 by I square, this is minus of minus plus 1, and this is 4i. So if I multiply with I in the numerator as well as denominator, this is I square minus 1. So this is going to become plus, and this is plus I by I square. This is minus 4. And therefore, see here, if I send this to the numerator, and therefore the residue, see here, the residue of f of z at point z is equal to minus I is nothing but minus 2 plus I by 4. And this is our corresponding residue value. This is our corresponding residue value for the pole value z is equal to -1. And the next thing here is we have to find the residue for the pole z is equal to z naught is equal to I. For z naught is equal to I, see here, I am doing for z naught. For z naught is equal to plus I. So here our residue value of f of z at point z is equal to plus I is nothing but the numerator I am leaving as it is, that is 2z plus 1 by minus 4z cube at point z is equal to I. Now if I substitute here, this will be 2i plus 1 by minus 4 into I cube. So this will be 2i plus 1 by I square, this is minus of minus plus 1 into 4. So this value will be, so if I multiply with I in the numerator as well as denominator, and see this is minus 2 I square, this is minus 1 plus I by here also this is minus 4. So if I take common from this, that is 2 minus I by minus 4. So if I cancel this one, so residue of f of z at point z is equal to I is nothing but 2 minus I by 4. So this is our residue value, the fourth residue value for the corresponding pole z is equal to I. And see, once again I'll explain you. The first thing here what I have done is, the question here is given as f of z is equal to 2z plus 1 by 1 minus z power 4. So in order to get the poles, we have to equate the denominator to 0, and as we got 4 pole values, that is minus 1 plus 1 minus I and plus I. So for this kind of function, that is u by v rule, so we have to apply this function, that is phi of z by xi of z. The first function we have to take phi of z, and the denominator we have to take xi of z. So in order to get the pole values, so we have to leave the numerator as it is, and we have to make a derivative for the denominator, and again we have to substitute our pole value. So first pole value is nothing but z is equal to, so first pole value is z naught is equal to -1. I have taken this -1, and therefore the numerator value I have left as it is, and for the denominator I made a derivative. This will be -4 by z cube, and in this I have kept z is equal to -1, and this is our residue value for the corresponding pole z is equal to -1. And next one, the second pole here is +1. So for +1, again the numerator I have to leave as it is. For the denominator I have to make a derivative and substitute z is equal to 1, and this is the residue value for the corresponding pole +1. And the next one here is -1. For -1, for z naught is equal to -1, so we have to leave the numerator as it is. We have to make a derivative for the denominator, and again we have to substitute z naught as -1, and this is our corresponding residue value. And the next thing here is for z is equal to I, which is again a simple pole. For z is equal to I, numerator as it is, denominator I made a derivative and substituted z value as I, and this is our corresponding residue value. So these are all the 4 residue values for the corresponding poles minus 1, plus 1, minus I, plus I. So this is plus or minus 1 and plus or minus I. So these are the residue values. Thank you so much for watching and staying till the end. So if you really like this video, you know what to do. Please subscribe and support this channel.